Welcome to SS2 Further Mathematics, Term 3, Week 1. Complex numbers extend the real number system to include the square root of negative numbers, something impossible in ordinary algebra. They are not just a mathematical curiosity, they are essential in electrical engineering, AC circuit analysis, quantum mechanics, signal processing, and control systems. By the end of this lesson, you will define imaginary and complex numbers, perform arithmetic operations on complex numbers, find modulus and argument, compute complex conjugates, and solve WAEC further mathematics problems. Let us begin. In real numbers, the square root of a negative number is undefined. This is because no real number, when squared, gives a negative result. Imaginary unit, we define I equals square root, minus 1, so I superscript 2 equals minus 1. This is the fundamental definition, accept it as a mathematical definition even if it seems impossible. Powers of I superscript 1 equals I superscript 2 equals minus 1, I superscript 3 equals I superscript 2 times I equals minus 1 times I equals I equals I superscript 2 equals minus 1, superscript 2 equals 1, I equals I. The cycle repeats with period 4. Square root minus 9 equals square root 9 times minus 1 equals square root 9 times square root minus 1 equals 3i. Square root minus 16 equals 4i. Square root minus 2 equals I square root 2. Complex number. A complex number Z has the form Z equals A plus B, where A equals real part, Z, B equals imaginary part, Z and B are real numbers. Examples: 3 plus 4i, A equals 3, B equals 4, minus 2, A equals minus 2, B equals minus 1, 5, A equals 5, B equals 0. A real number is a special case of complex. 3i, A equals 0, B equals 3, purely imaginary. Two complex numbers Z1 equals A plus B and Z2 equals C plus D are equal if and only if A equals C and B equals D, real parts equal and imaginary parts equal. Addition and subtraction, add/subtract real and imaginary parts separately. A plus B plus C plus D equals A plus C plus B plus D. A plus B, C plus D equals A, C plus B, D. Examples: 3 plus 4i plus 1, 2i equals 3 plus 1 plus 4 to 2, I equals 4 plus 2i. 5, 3i, 2 plus I equals 5-2 plus minus 3 to 1, I equals 3, 4i. Multiplication, expand brackets and use I superscript 2 equals minus 1. A plus B, C plus D equals AC plus ADI plus BCI plus B superscript 2 equals AC plus ADI plus BCI, BD equals AC, BD plus add plus BC. Examples: 2 plus 3i, 1 plus 4i equals 2 plus 8i plus 3i plus 12i superscript 2 equals 2 plus 11i plus 12, minus 1, equals 2 minus 12 plus 11i is equal to minus 10 plus 11i. 1 plus I, 1, I equals 1, I superscript 2 equals 1, minus 1 equals 2, a real number. This is important for division. Complex conjugate, for Z equals A plus B, the conjugate is Z asterisk, or Z with bar, equals A, by. The product of a complex number and its conjugate, Z times Z asterisk equals A plus B, A, by, equals A superscript 2, by, superscript 2 equals A superscript 2, B superscript 2 I superscript 2 equals A superscript 2 plus B superscript 2, always a non-negative real number. Division of complex numbers, multiply numerator and denominator by the conjugate of the denominator. A plus B, / C plus D, equals A plus B, C, D, / equals / C superscript 2 plus D superscript 2. Example: 3 plus I, / 2 plus I equals 3 plus I, 2, I, / equals 6, 3i plus 2i, I superscript 2, / 4 plus 1 equals 6, I plus 1, / 5 equals 7, I/5 equals 7/5, I/5 equals 1.4, 0.2 I. Always write final answer in standard form a plus by. Modulus of a complex number z equals a plus by, z equals square root, a superscript 2 plus b superscript 2. This is the distance from the origin to the point, a, b, in the complex plane, Argand diagram, see next lesson. Examples, 3 plus 4i equals square root, 9 plus 16 equals square root 25 equals 5. 1, I equals square root, 1 plus 1 equals square root 2. Dash 2 plus 2i equals square root, 4 plus 4 equals square root 8 equals 2 square root 2. Properties of modulus, z1 times z2 equals z1 times z2, z1 slash z2 equals z1 forward slash z2, z asterisk equals z, z superscript 2 equals z times z star. Argument of a complex number arg, z equals theta, the angle that the line from the origin to a, b, makes with the positive real axis. Theta equals arctan, b slash a, but care must be taken with the quadrant. Convention, principal argument is in the range, pi, or equivalently, minus 180 degrees, 180 degrees. Finding arg, z find the reference angle alpha equals arctan, b forward slash a, then adjust sign based on quadrant, q1, a greater than 0, b greater than 0 theta equals alpha, q2, a 0, b 0 theta equals pi, alpha, q3, a 0, b 0 theta equals dash, pi, alpha equals alpha, pi, q4 is a 0, b less than 0 theta equals alpha. Examples, arg, 1 plus I square root 3 equals arctan, square root 3 slash 1 equals 60 degrees equals pi slash 3, q1. Arg, minus 1 plus I equals pi, arctan, 1 slash 1 equals pi, 45 degrees equals 135 degrees equals 3 pi slash 4, q2. Arg, minus 1, I equals dash, pi, 45 degrees equals minus 135 degrees equals dash 3 pi slash 4, q3. Arg, 1, I equals arctan, 1 slash 1 equals minus 45 degrees equals pi slash 4, q4. Polar form, z equals z, cosine theta plus I sin theta equals r, or cosine theta plus I sin theta equals r cis theta, where r equals z and theta equals arg, z. Finding the square root of a complex number, let square root z plus by equals x plus e. Then, x plus e, superscript 2 equals a plus by. X superscript 2, y superscript 2 plus 2 z equals a plus by. Equating real and imaginary parts, x superscript 2, y superscript 2 equals a, 2xy equals b. Also, x plus e superscript 2 equals square root, a plus by, superscript 2 x superscript 2 plus y superscript 2 equals square root, a superscript 2 plus b superscript 2. Solving this simultaneously gives x and y. Worked example, find square root, 3 plus 4i. X superscript 2 plus y superscript 2 equals 3 plus 4i equals 5, x superscript 2, y superscript 2 equals 3, 2xy equals 4xy equals 2. Adding, 2x superscript 2 equals 8x superscript 2 equals 4x equals plus or minus 2. Then y equals 2 slash x, if x equals 2, y equals 1, if x equals minus 2, y equals minus 1. Square root, 3 plus 4i equals plus or minus, 2 plus I. Solving quadratic equations with complex roots, x superscript 2, 2x plus 5 is equal to 0. Discriminate equals 4 minus 20 is equal to minus 16 and 0. X equals 2 plus or minus square root, minus 16, slash 2 equals 2 plus or minus 4i, slash 2 equals 1 plus or minus 2i. If a polynomial with real coefficients has complex roots, they come in conjugate pairs. If 1 plus 2i is a root, so is 1, 2i. This is the complex conjugate root theorem. WAEC Further Mathematics exam patterns: perform addition, subtraction, multiplication, and division of complex numbers, find modulus and argument, express in polar form, find square roots, solve quadratic equations with complex roots, use conjugate root theorem. Key points: I equals square root, -1, I superscript 2 equals -1, I superscript 3 equals, I equals 1, cycle of 4. Complex number Z equals A plus by, A equals real part, B equals imaginary part. Operations: addition/subtraction, combine like parts, multiplication, expand and use I superscript 2 equals -1, division, multiply by conjugate of denominator. Complex conjugate: Z asterisk equals A, by, Z times Z asterisk equals A superscript 2 plus B superscript 2, real. Modulus: Z equals square root, A superscript 2 plus B superscript 2, with distance from origin. Argument: arg, Z equals angle with positive real axis, range, pi. Polar form: Z equals R, cosine theta plus I sin theta, equals R cis theta, square roots of complex numbers, use, x plus E, superscript 2 equals A plus by and equate parts. Conjugate root theorem: complex roots of real coefficient polynomials come in conjugate pairs.